current AI image generation sucks. And here's what I mean. Yes, you can do simple text to image, but what if you want to use another person's face? Well, you'll need to train a LoRa, or basically another AI model, on multiple photos of that person, including the correct labels, and then apply it to the image generation, which is quite tedious and wastes a lot of time. And what if you want to insert two characters in the same photo? Well, that's even more complicated. And what if you want to specify a certain pose? Well, you're gonna need another tool called controlnet, using an open pose processor, so you can get the pose you want. And what if you want to specify the outfit of someone? Well, again, you'll need another tool like Kling's virtual try-on to get this to work. Now, what if you want to unblur the image, or brighten the image, or change the color of a certain object in an image, or replace an object in an image? It's possible, but it requires multiple steps and multiple external tools. But this AI that I'm going to show you today solves everything. It's pretty damn amazing. So this tool is called OmniGen, and this was made by the Beijing Academy of AI. And here's what it can do. First of all, it can do standard stuff like text to image, and it can handle a quite complicated prompt with a lot of details as well, and it can understand the context. So for example, here is a cute cat hanging a card that only says OmniGen, quality details, etc., etc. And here we have a cat with a card that says OmniGen. Here is a young woman with fair skin, blonde hair, dressed minimally against a magenta background, hair pulled back, serene expression, light brown eyes, natural eyebrows, well-structured nose, etc., etc. And indeed, that is what we get. On the left, a golden retriever sits with its tongue out. On the right, a tabby cat lounges lazily, stretching its legs out and looking towards the dog, and this is what we get. Here's another example. Leaves made of ice, a muscular man with prominent muscular lines, a cheeseburger surfing the vibe wave at night, a bright red rose, petals scattered with some water droplets. But that's just basic stuff. I mean, all the state-of-the-art image generators like Flux or Stable Diffusion right now can do this to some extent. But here's where OmniGen really stands out. First, you can ask it to analyze the image and manipulate it just by talking to it like a chatbot. So, for example, if you prompt it with, "Where can I wash my hands? Please help me find the right place," and then you upload this image, well, it has identified that the sink is where you can wash your hands, so it has highlighted the sink in the image. Here's another example. What can be used to hold water? Remove it. So in the image it's scanning, well, the only thing that can hold water here is this cup. So for its output, it has removed the cup. And it gets even better. So let's say you want to add two characters in the same photo. Right now with Flux and Stable Diffusion, you need to train a LoRa on multiple photos of a character. You need to label all the photos. Then you need to train the damn model. It's just so much time and effort. But with OmniGen, none of this is necessary. You no longer need to train any LoRa model on multiple photos of a person. All you have to do is upload two photos. So for example, here the user uploaded a photo of Wukong and Iron Man. And the prompt is, in a cozy kitchen, man 1 is chopping vegetables while man 2 is sitting nearby. Several delicious dishes are laid out on the table. Man 1 is the person with closed eyes in image 1, which is Wukong here. And then man 2 is the person who is in the middle of image 2. So this is image 2. And what we get is indeed Wukong and Iron Man in a kitchen. And Wukong is chopping vegetables and there are delicious dishes on the table. How crazy is that? There's no longer any need to train LoRas anymore. You can just upload a photo and then prompt it to generate a photo of your reference character. Here's another super realistic example. All you need to do is upload one image of each character. So here's Bill Gates, here's Jack Ma. So the prompt is man 1, which is Bill Gates, is positioned on the left side of the image, leaning forward as he engages in conversation. On the right, man 2, Jack Ma, is animatedly gesturing with his hand. The background is filled with etc., etc. So the prompt is too long to fit in here, but here's what we get. And indeed, on the left, we have Bill Gates. On the right, we have Jack Ma. And look how realistic this photo looks. This looks exactly like Bill Gates and Jack Ma. And the fact that this is like their side profile, whereas we only uploaded photos of them looking directly at the camera, I mean, this generation is insanely impressive. And it doesn't just work with people, it can also work with objects or animals. So for example, here is a photo of Einstein, here's a photo of a Mac. So if you input these two photos and then you say man 1 is seated on a desk with a laptop in front of him, his eyes are fixed on the screen, etc., etc. Man 1 is the elderly person with white hair in image 1, which is this one. And then the laptop is image 2. Here is what we get. How cool is that? And yes, animals work as well. So if you input this image of a dog and then the prompt is a dog, image 1, in a chef outfit, that's indeed what it generates. Here is a dog, image 1, adorned in an astronaut suit situated within the cosmos, and that's indeed what we see. Here is a cat, image 1, in the snow, and that is indeed what it generates. And here's another example. Woman 1 is holding a cat and sitting on a bench in the park. The background shows lush green trees, etc., etc. The woman is the person smiling in the camera in image 1, all right? And then the cat is the one in image 2, which is this one. And this is even trickier because the user has uploaded an image of both a cat and a dog. But because this has natural language abilities built into it, it knows to identify only the cat in image 2 and not the dog. And here is what we get. Here is indeed Queen Elizabeth holding a cat sitting on a bench in a park. But that's not all. You can now say goodbye to controlnet. You no longer need controlnet to generate depth maps or poses or whatever. I mean, it's just a few extra steps that is quite cumbersome to do. But this model has controlnet built in. So for example, here's the input image. And now if you just prompt it with detect the skeleton of the human in this image, you get a pose image. And then same thing, if you simply prompt it to output the edge detection for this image, you get this output. And if you prompt it to generate a depth map, you get this. Here's another example. All you need to do is upload some reference. So for example, here's a depth map. And then if you prompt it with a white stallion horse galloping furiously, kicking up the dust behind it, well, it generates that using your depth map as a reference. So here's another example. Here's the input, and the prompt is a woman in a white turtleneck, and indeed, that is what it outputs based on this reference image. Here's another one. So the input is this segmentation map, and the prompt is a bedroom with a large bed. And this is indeed what it outputs. Here's another example. Following the depth map of this image generates a new image. An old man is walking in the park. So indeed, it has generated an old man, but this is aligned with the depth of this original image. And here's another even crazier example showing why it's super powerful. You can do multiple tasks at the same time. So here, for example, here's the original input image. And then if you prompt it with inpainting, so basically fill in this part, which is black, plus change the color of the hair to white, it does both these steps in just one go. Here's another example. So here's the input, add sunglasses to the man's face, and change the color of the clothes to blue. And that's exactly what it did. It did both steps, adding the sunglasses and changing his shirt to blue, all in one step. Just think of the power and flexibility you can have with this tool. This makes it so much more intuitive. Before, you actually need to learn controlnet, you need to learn image to image, you need to learn all these external tools and know when to apply them in order to get your desired effect. But right now, everything is just built in. If you want to change the brightness, if you want to change the pose, if you want to change the composition or the color of something, if you want to do anything with the image, all you need to do is prompt it on what you want it to change. It's that simple. Here's another example. Here's the input image, here's the prompt. Put a smile face on the note. So now instead of the note saying I miss you, it now turns into a smiley face with a cute little heart symbol as well. Or here's another example. The canny edge of the generated picture should look like the one below. And then if you upload this as a reference, the output looks like this. And indeed, it does match this original edge image. Here's another example. So here are two input images, and then if you prompt it with reveal the person's appearance in this suit, image 2, that is what you get. It basically changes this person's shirt into the red shirt. So you no longer need these complex virtual try-on tools. All you got to do is upload your model's image, upload any piece of clothing, and then prompt it to change into that piece of clothing. Here's another example where you can easily turn an image from one style to another. So make this image 1 here, the same style of image 2, which looks like this. And indeed, that is what it does. And there's more things you can do that you definitely cannot easily do in one step with Flux or Stable Diffusion nowadays. So if you have this blurry image and you get it to unblur the image, well, it can do that. So, all these other image editing tools like Topaz or Photoshop, they're going to get crushed by this. Here's another example. This is a really dark image. And if you simply ask it to brighten the image, it does exactly that. Here's another example. Detect the skeleton, or basically the pose image of the human in this image. And that's what it does. Find all the window panes in the photo and outline them in blue. And that's exactly what it does as well. You can also upload a reference of what you wanted to do for an image. So for example, here we have 3 images. If the input is this and the output is this, so it's basically a depth map, do the same for this image. And that's exactly what it does. It generates a depth map based on this image. Or here's an example of inpainting, but you're not explicitly telling it to inpaint. So for example, if the input is this and the output is this, do the same for this image. And it learns that, all right, well, basically I need to inpaint this block of black here. So I'm going to do the same for this image. And that is exactly what we get. I mean, just think of how powerful this is. You can change any image to whatever you want just by prompting it. So for example, here, add the word Apple below the Apple logo. And here is what we got. No more inpainting, no more image to image, no more of these complex workflows that you see in Comfy UI or Automatic 1111. All you need to do is prompt it and it will add it for you. Here, remove the butter on the cake, and that's indeed what it does. Here's the input image. You prompt it with delete the rain in this image, and it actually does that really well. Here's another example. De-blur this image. Here's the input image, and it does unblur the image. So here's an illustration of how quick and powerful OmniGen is compared to current methods. So right now, if you want to generate something with the same pose of the original image, well, first you need to detect the pose and generate a skeleton of that person, and then use controlnet to actually generate an old man with that pose. But with OmniGen, it's just one step. All you need to do is prompt it by saying, generate an old man with the same pose as this woman. Here's another example. So let's say instead of pose, you want to use a depth map. Well, again, the way we have to do it right now is you need to generate a depth map of the image first and then plug it into controlnet to generate the image. And the image isn't even that good. But now with OmniGen, all you need to do is prompt it by saying, generate an old man based on the depth map of this original image. So as you can see, OmniGen is insanely powerful. It brings together image generation and computer vision into one single tool. Other image generators out there, they need extra tools or external tools to handle different tasks like image to image, inpainting, training loras, etc. But OmniGen just does it all in one place. This makes it much easier and way more intuitive to use. And the crazy thing is, it can even learn new things and generate new ideas, which I'll go over in a second. But first, let's actually look at how this works. There are very few software tools that I use every day, but this is one of them, thanks to our sponsor, TurboType. Basically, you can create custom keyboard shortcuts so that you don't need to keep typing out repetitive things. So check this out. Let's say there's a prompt that I use often in ChatGPT. Let's set the shortcut to /sum, and then I'll type in the prompt that I use often. I can even add in a variable to include any text that I copy. And then let's say I find an article that I want to summarize. Well, I can just copy the URL and then in ChatGPT type in my keyboard shortcut and voila, super quick way to write prompts. You can also drag and drop shortcuts onto any text field. I can also select any text and then right click to easily add it as a shortcut. Finally, it also supports rich text. For example, you can add in bold and italics and add links to your text as well. So let's say I need to send out a lot of cold emails with the following template. Well, I can just create a shortcut for that. And then whenever I start an email, I just need to type in the shortcut and voila, the text is already styled and linked for me. There are hundreds of pre-existing templates that you can choose from, including common prompts for ChatGPT, business, finance, medicine, and more. This tool saves me so much time every day, so definitely check it out and download the free Chrome extension in the link below. So OmniGen still uses a diffusion model as its foundation, similar to Flux and Stable Diffusion. However, its architecture is very different and actually a lot simpler in some regards. So here's the architecture. It still consists of a variational autoencoder, also known as a VAE, and you should be familiar with this term if you've been using Comfy UI. This basically encodes or decodes an image into latent space. It also includes a pre-trained large language model and, of course, a diffusion model. And this combination allows OmniGen to handle both image generation and traditional computer vision tasks within a single framework. So you can ask it anything about the image, you can ask it to identify objects in the image, and it would understand it because of this architecture, because of this combination of computer vision and image generation. And like I showed you before, everything is unified. So unlike existing diffusion models, which are task specific, OmniGen is a unified model which can do pretty much everything from text to image editing, generating specific characters, extracting certain objects, extracting different poses and depth maps, and more. So this is a huge improvement from what we have existing right now. Currently, we need all these different tools like IP adapter, controlnet, and we need to actually specify the settings and conditions for each one of these external tools, which takes a lot of time and effort to implement. It's not as intuitive to use. So here on the left, this is the OmniGen architecture. On the right, this is the classic Stable Diffusion architecture. Now, if you compare the two, actually OmniGen is simpler in a sense. It doesn't require additional text encoders, making it more user-friendly. On the other hand, existing diffusion models, they often use an encoder-decoder architecture that requires an additional encoder to process text conditions. If this is too complicated for you, don't worry. All this means is that with OmniGen, complex tasks can be accomplished through simple instructions without extra pre-processing steps. By the way, here's another impressive thing about it. It was trained on a very small dataset of only 0.1 billion images, compared to Stable Diffusion, which was trained on over 1 billion images. So this is 10 times fewer images compared to Stable Diffusion. But its performance on the Gen Eval benchmark is actually similar to Stable Diffusion 3. Now, here's the crazy thing about it. By being trained on a unified platform, OmniGen can effectively transfer knowledge learned across different tasks. And this allows it to handle tasks it has never seen before in its training data. And this could lead to novel capabilities. This is the complete opposite of existing diffusion models, which struggle to handle things it has never seen before, because it was never trained on that data. So instead of taking my word for it, here are some specific examples. I showed you this example before, but basically OmniGen has the ability to extract certain spatial information from the image, such as the pose skeleton, the edge map, and the depth map of an image. However, note that it was never explicitly trained on this data. It was never trained on how to generate a depth map or a pose skeleton, for example. And it has no skeleton generation model built in. But somehow, through this training, through this architecture, it was able to implicitly learn that skeleton maps look like this, edge maps look like this, depth maps look like this, and it kind of learned how to generate these kinds of maps from an input image. So this is an example of knowledge transfer. It just learned about this concept, but it was never trained on it. Here's another example I showed you before. It was never trained on handling multiple instructions at once. So as I've shown you before, here we are adding sunglasses to the man and changing the color of his shirt. Note that OmniGen was only ever trained on single tasks. It was never trained on doing multiple tasks at the same time. So the fact that it was able to pull this off is another example of an emergent ability that it kind of just figured out by itself. Another impressive observation is that it can learn in context. So here it was prompted with an image of a scribble, and then here is an image of a turtle, and then the prompt is, if this is the input, this is the output. And so now if this is the input, what should the output be? Now note that it has never seen these types of scribble images in its training data before, but after the user feeds it with these images, it was able to accurately generate a realistic depiction of this. So similarly, it can kind of learn on the fly. So for example, it has no idea what a pencil sharpener is. So If you just feed it an image and then you ask it identify the pencil sharpener in the image and highlight it in blue, it's not going to be able to highlight this. It has no idea that this is a pencil sharpener. It also doesn't really know the queen piece in chess. So if you upload this image and then you ask it find all the chess queen in the image and highlight them in blue, it kind of highlights everything. It gets it wrong. However, the way around this is you kind of get it to learn what a pencil sharpener is. So if you instead upload 2 other images of a pencil sharpener, and then you say if the input is this and the output is this, so you have the pencil sharpener highlighted, and then you feed it this new image of a pencil sharpener, and you ask it what would the output be, then it can successfully highlight the pencil sharpener. Same with this example of the chess piece. So if you upload these 2 reference images, and if you say this is the input, this is the output, so this piece is highlighted, and now if you ask it if this is the input, what should the output be, then it was able to successfully highlight this queen piece. So it can kind of learn from reference images that you feed it as well. Now, while this can do a lot of cool things, this is definitely a lot better than the image generators we have so far. OmniGen does have limitations. The first limitation is that it relies heavily on the details of your text prompt. So if you give it a vague or incomplete prompt, it could lead to inaccurate or undesired results. But actually, this is quite common for all the image generators we're using right now. I mean, even for Flux and Stable Diffusion, they do better with more detailed prompts. It also doesn't do well with long sequences of text. So if you try to input this text, in this work, we introduce OmniGen, a novel unified model for etc., you can see that the text is not great. And by the way, if you're looking to generate a lot of text in your image, the best tool for that is Ideogram, so definitely check that out if you haven't already. Anyways, going back to OmniGen, here's another common issue. It cannot generate perfect hands and fingers some of the time. So you can see this finger is kind of messed up here. And then same with this example, the hands and fingers are just really messed up here. And as you probably know, this is very common for all the image generators we have right now. I mean, even the best one out there, Flux, is not perfect. It is better at generating hands and fingers, but some of the time it still fails and gives you some weird results. So, I mean, this is just one of those things which is really damn hard for AI to generate. Another limitation is that it doesn't do well with image types that it has never seen before. So, for example, it has never seen this surface normal estimation image in its training data. So, if for the prompt you input these 3 images and you say, if this is the input, this is the output. Now, if this is the input, what would the output be? Well, it kind of failed to generate a surface normal image that looks like this. So there are instances where it cannot generate something it has never seen before. But anyways, even with all those limitations, you can see how powerful this tool can be. It really removes the need for any graphic designer or any photographer. Let's say you're an e-commerce business. You no longer need to pay for any professional product photo shoot. All you need to do is upload an image of your product and then prompt this AI to generate a professional quality photo of the product. The same goes for any other type of photography or graphic design. I mean, this is just a research paper. This is in its very early stages, but I think this does have the potential to kill Photoshop. This AI, in theory, could just create anything you prompt it to create. It can manipulate any image or any object in the image. And of course, with this power, there's definitely potential for abuse here. So for example, someone could easily upload an image of Bob and then prompt the AI to generate an image of Bob stabbing a woman and then use that as evidence in court. But of course, this also unleashes a ton of creative power for photography and graphic design. Anyways, that sums it up for this research paper. The great thing is they are aiming to open source this. They haven't released the code yet at the time of this recording, but this just seems really cool and I just wanted to share this with you as soon as I found out about it. But rest assured that I will do a follow-up video on this as soon as they release the code. I'm dying to try this out, so I'll definitely show you how to install it and use it and do a full review on it, so stay tuned for that video. Anyways, let me know in the comments what you think of this, and what would you use it for? Do you think this will replace current AI image generators out there, and will this become the dominant image generator? Let me know in the comments below. As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week, I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.